All right, we need to fashion the parity check matrix H transpose, and we'll do this given the critical piece of information, the P matrix, which was part of the generator matrix in the Hamming block code transmitter or channel encoder. The P matrix is Q by K in size. And we need to fashion ultimately a P matrix stacked on top of an identity matrix, which is Q by Q. So let's see if we can figure out how to extract that value Q from the matrix dimension. So using the array size node, and I'll just go ahead and put something in here. This is not necessarily trying to represent a valid P matrix, but just to get some numerical values in there. We see that this is a 2 by 3 matrix, and sure enough, there's the 2 and there's the 3. So it appears that the desired value Q is the second element in this array. Let's use index array to pull off that element. So again, all arrays always start at 0, where our second element then would have an index of 1. Alright, and there's our Q value showing up, and that's ready for further use in the subVI. Now I'll turn attention to the identity matrix. Matrix type actually defaults to identity, so it's truly not necessary to put that constant out there, but I think it's a nice reminder about what you're actually in fact generating. You can then use build array to concatenate the P matrix, actually the P matrix, not the value of Q. Let's try that again. Again, this value would specify our matrix size, so you could go ahead and complete that connection. We then take the identity matrix that's being generated and put that underneath the P matrix. Well, let's generate an indicator. And looking carefully at this, you'll see we've actually generated a three-dimensional array, which is not correct. We're trying to get a two-dimensional matrix out of this. Also, if you look carefully, you can see the data type is indicating a larger array. What we really wanted to do was concatenate the inputs. Let me try creating a new indicator and see how we're doing. Alright, that looks better. Now we've got a two-dimensional matrix as a result.